I'm Spencer Curley from University of California, Irvine, and Ed Manucchi's lab, and I am going to demonstrate how to do cryosectioning. To do that, I use these commonly used reagents. First, the embedding compound or embedding media that I use is called OCT, for optimal cutting temperature. It's a clear solution. It's very thick and viscous, and it holds the tissue nicely while you can orient it. And then it freezes, and ultimately it's water soluble, so you can get rid of it during any type of staining procedure. So I embed the tissue in a mold, these cryomold biopsy containers. They come in various sizes. I will be using this smaller mold here because I do embryonic tissue from mouse. We flash freeze our tissue in liquid nitrogen, so first I'm going to fill this protective vacuum flask with liquid nitrogen from our tank here. Prior to flash freezing the tissue, you have to what's called cryoprotect the tissue. Otherwise, freezing itself will destroy the tissue. So what you do is you sink the tissue in a 30% sucrose solution overnight. And if it takes longer, that's all right, just as long as the tissue sinks. And as you can see, these embryonic day 12.5 mouse heads have sunk in the sucrose solution, so they are ready to be frozen. So now I'm going to simply pour the tissue that's in the sucrose solution into a larger dish so I can manipulate the tissue. I'm going to take some of this OCT and pour it into this 35mm dish that is actually resting on its lid, so I can get it at an angle so the OCT pools along the edge for depth. So I'm using a pair of older blunted forceps simply because you don't need them to be sharp, and you don't want to ruin another pair of forceps. So I take them and I lift one of these heads out very gently, and I place it into this first bath of OCT. I just want to coat the embryo in OCT. This allows for better, more uniform freezing of the tissue. You don't want any residual sucrose around the tissue or any air bubbles. Definitely avoid air bubbles. So I'm just gently stirring the OCT around and under the head, moving the head through the OCT. I'll let it sit there for just a few seconds while I fill my cryo mold. So now I'm going to fill the cryo mold with the OCT, again avoiding bubbles, and I'm just going to fill it up to the top of the mold. And as you'll notice, I've labeled the mold, so I'll be able to see my orientation after it's frozen. When the OCT freezes, it turns white, and you can no longer see your tissue. So you definitely want to label in a permanent marker the cryo mold. I actually did get a bubble in the OCT, so I'm going to use my forceps to just push it out over the edge. You don't want that to interfere with with the freezing of your tissue. So now I am going to transfer the head from this dish into the OCT that's in my mold. I'm just going to lift it out of the dish and place it into the mold very gently. Then I'm going to go to the microscope where I will orient the tissue. I've got the tissue in my cryomold here, and I'm going to look through the scope so I can orient it. I'm going to be doing coronal sections through this mouse head, so I need to orient it so that I can position it in the cryostat for coronal sections. So again, I'm using these old blunted forceps. And as you can see, there are some bubbles here, and I'm going to try my best to get them out, but these smaller bubbles aren't bad. I haven't noticed anything with these smaller bubbles. You just don't want large bubbles, so I'm just going to scoot them out as best I can. And definitely wipe the forceps often, because you can avoid bubbles better that way. And now, if you can see my labeling, I have a T up here to the top and an F to my left here. That just indicates to me that the top of the head is going to be up, and the front, or the face, is going to be to my left. That way I know which surface to section through for coronal sections. Now I'm just nudging the tissue. And again, sometimes that introduces bubbles, and you just want to push them out so that they don't freeze alongside the tissue. So it's bad to have bubbles, mainly because when you're freezing the tissue, bubbles can cause inconsistent freezing. The purpose for flash freezing is to have everything frozen at once. Also, when you're cutting through the tissue in the cryostat, if the blade goes through a bubble rather than the OCT or the tissue, it can cause a snag or a tear and destroy or break your tissue. So you definitely want to avoid these bubbles at all costs, the larger ones especially. So I'm still orienting it here. This tissue has been fixed for 24 hours, so it's pretty sturdy to my manipulations. Other tissue might be a bit softer, so you just want to be very gentle. So once I have it positioned under the scope with the face to the left and the top of the head up, I'm going to need to make sure it's correct in other planes of orientation as well. So I'm going to lift and look through all the faces of the cube to make sure that it's right, and I see that it is angled down slightly, so I have to just lift with my forceps. Okay. And this definitely takes a lot of practice. Okay, it looks good. Now I'm going to walk over here and freeze it in liquid nitrogen. Now that the tissue is oriented properly in the cryomold, I'm going to pour my liquid nitrogen into this dish here. This is just a normal plastic petri dish for tissue culture. Just up to the top. It evaporates pretty quickly. I'm going to take my forceps and lower the cryomold, and as you can see, I've actually bent the bottom lip. That definitely allows for better handling. I'm going to freeze it, and as the tissue in OCT freezes, it turns a solid white. And once it's complete, it'll all be white, and then I have to quickly place the frozen tissue into the -80 freezer for storage. You want to hold it such that the tissue does not get submerged. So you have to be very careful just to hold it in the top surface of liquid nitrogen. Okay, now it's frozen. Hold it there for a few extra seconds before I go to the -80. Okay, now I'm going to take it to the -80. So I've taken my tissue from the -80 and placed it into this cryostat here. The chamber is actually down to -24 degrees Celsius right now. You have to let the tissue equilibrate for about a half an hour to an hour before you can start sectioning. Otherwise it's too brittle. So while All cryostats are different. I'm just going to point out some of the basic things about this machine here. So we use the Leica CM3050S. It's a good machine because it has a separate cooling unit for the specimen itself, which is a nice added benefit. You can have the specimen temperature set, and different tissues require different temperatures for cutting. So when you first load your tissue, you need to make several adjustments, and these are similar on all cryostats. These are electronic, some of them are hand operated. For instance, you'll need to retract the arm of the cryostat or advance it to position it further or closer to the blade. You can do that fast or slow. You can set the thickness of your cutting with this plus or minus here, and you'll select between trim or section thickness, which is indicated in the middle button here. You'll set the temperature of the chamber or the specimen itself up next to this digital display simply by pressing this and using these up or down arrows to adjust the temperature. So for us, when we do cryosectioning, we use these Fisher brand Super Frost Plus microscope slides. They are coated with some adhesive so that the tissue during processing doesn't come off. Sometimes during sectioning you'll notice that the tissue seems a bit soft, and some indications of that will be if it hits the blade and bunches up. And what you can use to fix that is this Fisher brand Super Friendly Freeze It. It flash freezes the tissue, and you just aim it at your tissue and press the trigger, and it'll quickly refreeze the tissue if it's too soft. Before mounting the tissue onto a chuck for sectioning, I'd like to take you on a quick tour of some of the things in the machine here. So this is where you actually load the blade, which is secured with this metal plate. By pulling up this arm, you can actually remove and replace the blade as needed. Make sure it's nice and secure. You don't want to over-secure the blade, otherwise it actually gets warped, and you'll notice in your sectioning that the tissue thickness isn't consistent. So you don't want to push this arm all the way down. You want to just get it to where it's about even with the blade itself. This here is another thing you might have to adjust during sectioning. It's called the anti-roll plate. It's a piece of glass that fits into this holder here, and you can adjust it using this spring-loaded screw here, and you basically move it forward or backward, and that will keep your tissue or your sections flat so that you can mount them on a slide. Another thing you might like to adjust during sectioning is the place on the blade that is doing the actual cutting. So how do you adjust that is you simply lift this lever, and you can slide this whole contraption left or right. And you only use that really if you notice your tissue is snagging on a certain part of the blade, or you want to save blades because they are rather expensive. So you can find a nice clean area just by moving this back and forth. Another thing you can adjust is the angle of cutting. Now on the side here, which you won't be able to see, there are 3 different positions. We just use the middle position, and you adjust that by lifting this other lever, and that you can make this contraption go up and down. We always keep it in the middle, so I'm just going to keep it at that now. So this back here is the head of the cryostat. It'll actually hold the frozen tissue specimen as it's being sectioned. It swings up and down and advances towards the blade. Basically you mount the tissue on this chuck here, and we'll place the chuck in the head, tighten it down, and then use these knobs in the back to adjust the angle to make it a straighter cut. So now I'm going to mount the tissue onto the chuck. You want to keep the chucks at room temperature because you'll first add a layer of OCT, and you don't want that to freeze immediately because you want it to be a nice flat layer. And we'll use this contraption here to, it's called a heat extractor actually. It'll be used to flatten the OCT as it freezes. So what I do first is I take the room temperature chuck and I place it in this holder here. Take some of my OCT. Bubbles don't matter here because they'll be squeezed out. Just add a little, you don't need much. Take the heat extractor and just sit it right down there. Wait a few seconds. And then there you can see that the OCT is nice and flat. So now I've got my tissue and I need to mark the actual OCT. So I'll mark a point on the OCT to indicate its position. So there I've just marked the top with a blue dot. So now I'll take the block of tissue out of the mold, and I do that just by pushing against the back of it. So I'm going to push on the back gently and just push it into my hand, but again I don't want it to thaw, so I put it right back in. So now you can see the block of tissue with the blue mark that I put on it. So I know that's the top of the head of the embryo, and I want to section through the face because these are coronal sections. So now what I'll do is I'll add another droplet of OCT, a large droplet, and I have to act quickly now because everything's cold. And I'll take my tissue and place it right in the middle. Make sure it's flat against the bed of OCT I already made. Now I'll just let that freeze. That'll take about a minute or two. So now it's finished freezing, and I'm going to take the tissue that's mounted on the chuck, place it into the head, get it as straight as I can, and then tighten it. Okay, that's nice and tight. I'm gonna place it just in front of the blade and then advance it. Which could take several seconds. Okay, now I'm going to use the flat edge of the blade to really do fine positioning of the tissue. So I simply I'll look at the edge and swing the tissue up and down just to make sure that the edges line up. If they didn't, it could look something like this. I'm exaggerating it obviously, but you can see here that it's not straight against the blade. So I just keep making adjustments until I feel that it's as straight as I can get it. I think that's pretty good. So I look from every angle to make sure the tissue is going to cut straight against the blade, and I use the edge of the blade to indicate that. So I'm looking above and I'm looking from the side, and the tissue actually looks pretty good. I don't have to make many adjustments, but if I did, I would just use the knobs that are in the back of the head, and by turning those left or right, you can see that you can do fine adjustments that way. But it looks pretty good. Now I'm actually advancing the tissue. It's not cutting yet because it's not against the blade. The tissue's embedded inside, deep into the OCT, so it could take several minutes to get to the tissue. You don't want to go too fast because it could catch and crack the OCT and your tissue. But you also don't want to go too slow because it could take forever. There's one nice function on this machine where you can do a trim at a thicker section, which will allow you to go faster. So now I'm actually I'm cutting through the OCT now. So I'm slowing down a little bit. So I still haven't gotten to the tissue yet, but this is the time where I assess how the sectioning is going to go. A lot of variables can cause your tissue sectioning to go really well or really badly. What I find happens most often with this cryostat is that the tissue is actually a bit too cold. I've reduced the temperature, but still it seems that it's a little too cold. And what happens is that the blade will chatter through the tissue and through the OCT. So you'll get these small lines, these horizontal lines through the OCT. What I do is I'll take my thumb and I'll simply warm the edge up, warm the OCT up, just by gently touching it, sliding my thumb, not for very long. And then when I section through it, I notice they come out a lot better and the chattering has stopped. So those are the types of things that I'll assess before I get to the tissue. So I've noticed that as the blade goes through the tissue, there's a snag or crack actually in the OCT. So one of the things that I do first is change the blade. I'm not sure how long this blade has been on here and who used it before me. So I'm just going to go ahead and get a new blade out. These are very sharp, obviously, so you have to be careful. So I'm going to adjust the anti-roll plate, and there's a screw, spring-loaded screw on the bottom here that you just have to reach under and you can move it in or out. So I've advanced and sectioned enough so that now I'm into the tissue, and unfortunately there's a crack through the block of OCT, which happens often, and unfortunately you can't really control for it. But there are things you can do to fix it. If the crack had gone through the tissue, then you have to discard the sample or try to salvage what you can. In this case, the crack seems to be above the tissue. So what I'm going to do is take a razor blade that's been in the cryostat. It's chilled, and I'm going to try to just trim off the cracked part, which is at the top of the OCT block. So again, I'll use my thumb to heat up the face of the OCT block. And then I'm going to section through. And if you can see it here, it's cracked. So there I took off the piece with the tissue, and then the rest of the OCT that I just flung off, it was the cracked part. So what I'm going to do is I'm going to try to trim off that cracked part. Using a chilled razor blade. I have to go in very straight, and I have to use both hands and apply pressure evenly on the blade. And I'm going to rock the blade back and forth into the OCT. So I'm rocking back and forth, cutting slowly into the OCT. Hopefully I'm removing the cracked part. Okay. I'm going to cut down through, removing this excess OCT. Okay, looks good. I'm going to then retract the head slightly, because now I've created edges that can catch on the blade, and if that happens, it could actually break the OCT and tissue off, and which would ruin my sample. So I've retracted, so I'll need to advance a little bit more to get back into the tissue. And hopefully I've corrected the crack. Okay, now I'm getting back into the tissue. Okay, it looks like I did correct it, so there's no longer any cracks in the OCT. That'll make capturing the sections a lot easier. So now I'm going to advance to the part of the tissue that I'm interested in. Right now I'm just now hitting the surface, and I'd like to get into the brain of this embryo. These are large enough that I can actually see the structures that I'm interested in. I failed to mention that I use these brushes to clean off the blade between each section that I'm going to capture. This large one is just for cleaning off the area and removing the excess OCT. I also use these finer brushes to manipulate the section against this cold plate here to position it when I'm capturing it on the section. Again, these are kept cold so the OCT doesn't melt and stick to the brushes. So to capture the tissue, I'm going to first heat the OCT and tissue with my thumb, and I will take one of these slides that I've already labeled. I hold it upside down, and everyone does this differently, but the way I do it is I like to hold this top right corner when the slide is facing down with my right hand, and then use my left thumb as a pivot point so that I can go straight down against the plate and capture the section. The OCT and tissue will actually melt against the slide and mount itself. So first I'll warm the tissue with my thumb, slowly section through, grab my slide, hold the right corner with my right hand, move the plate, lower it straight down, let it melt. I'll look at the tissue to make sure there's no folds or bubbles, and it looks good. And I'll continue doing this until I section through the entire brain. I'm now looking at the sections through the dissecting scope to make sure that they look good, and they do. You can see the forebrain at the top of the section, and they all look very nice. You can use these cryosections for things like in situ hybridization. We sometimes do basic histology H&E stains. You can also do immunofluorescence and a number of assays like that. For me in particular, these sections were fixed and processed for in situ hybridization, so that's what I'll be doing next.